All right, set 2, Swyk number 1 of week 3. This particular question has a couple things. Well, number one, we're dealing with a fractional exponent. Okay, so instead of writing it like that, I chose to look at it like this: 3 over 2. We've talked about how the power is in the top is a 3 and the root in the bottom is a 2. Power over the root. So the power being on the top, root on the bottom, we want to deal with the root first. So if you take a look at, actually we'll deal with the power first. So when you look at it, there's two different ways we can write this, and I'm going to let you do it either way. It doesn't really matter. I think one way looks a little bit nicer, but it's all about what you think. So on the left here, you'll see that I wrote the square root of x minus 6, and then on the outside I wrote to the third power. Put the power on the outside. We can deal with that power first by, can't deal with the power first. We got to isolate the radical. Sorry, my bad. So we divided by 3. We got 27 on the right side when we did that because you had to get rid of this thing out in front. Okay, now we can deal with the power there by taking the cube root. And we took the cube root of 27 and we ended up with 3 when we did the cube root. Now we can deal with the radical because it's now uncovered. Basically had to peel away the onion layers, kind of like Shrek talked about, never mind. Okay, so getting rid of the radical, we square both sides. That gives me x minus 6 equals 9. And then you can add 6 to both sides and get 15. Now I want to show you another way to look at this problem. Okay, now step number 1, still the same. Still dividing by 3. Okay, got to get that down to 27. But I'm going to kind of zoom in on this because I think it's that important for you to kind of follow along. Look what I did with the exponent. I raised both sides to the 2/3 power. Now, why would I do the 2/3 power? Because what is 3/2 times 2/3? Yeah, folks, the 2's cancel and the 3's cancel. That gives you an exponent of 1. Nice. On the other side, you have 27 to the 2/3, which can be broken apart into 2 pieces. 27 to the 1/3, which we know that's the cube root of 27, which is 3. And then the square on the outside, so 3 squared is 9. So I like this idea of a reciprocal exponent. We had a 3/2 power, so we decided to multiply by 2/3. I shouldn't say multiply. We raised the power to the 2/3 on both sides. Now, I do understand that when you raise the power of the power property says you multiply them together, and that's why it gets, people like to say you're multiplying, but you're not really. You're raising it to a power. Well, once you get that down to here, where you're saying x minus 6 on the left and 9 on the right, add the 6, you got 15. So you get the same answer that we did before. It depends on which way you want to do it. Do you want to look at it with radicals, or do you just want to do that reciprocal of the exponent idea? I kind of like the reciprocal of the exponent idea, but I've seen it both ways, so it's not a big deal. However, on question 2, I'm going to use the idea of the reciprocal of the exponents. I did see in the very beginning of this question that we did have a +1 that was needed to be moved to the other side so that that radical or that power could be dealt with. And the reciprocal of 1/3, 3. So raise both sides to the third power. That gave me 2 to the third, which is 8. And then it's off to the races with the easy stuff, right? Subtract 5, divide by 2. And we get 3 over 2 or 1.5, whichever. Pay attention to the instructions on which way. It might take both answers. It should. They're both the same. So I don't see why it should not take one or the other, whichever one you type in, 3/2 or 1.5. Okay, we're going to get into some graphing now with radical functions. Remember that a square root function, I believe we talked about this a long time ago, a square root function looks like the top half of a sideways opening parabola. If you can kind of imagine a sideways opening parabola, Let's see if I could do this. You're, kind of like looking at it like this. Sorry, I'm just have to think backwards. It's the top half, right? Because it's positive square root of x. And then when it's on the outside, that plus 5 is on the outside, so that's going to deal with the up and down. And we've always said that if it's on the outside, it matches your common sense, so it goes up 5. Letter choice B is the one that takes that radical and shifts it up 5 units. Next. This time it's on the inside. That minus 5 is on the inside. And we know that when the change is on the inside, it's going to be shifting it either left or right. We always said it looks backwards of your common sense. This does go to the right 5 units, so pick that thing up, move it right 5 units, and you're dealing with something that looks like that. Remember, each one of the blocks on the x-axis is worth 2, not just 1, so that's why it is 5. Oh, sorry for yawning. I know you guys don't like it when I yawn. So this one would be left 2. It looks backwards on the inside. Remember, it always looks backwards on the inside. It looks exactly like what you think on the outside. And the only one that went left 2, so it's the exact same looking picture. It just got picked up and moved to the left 2. In the near future, we're going to be asking you about domain and range. Remember, all the x's, that kind of stuff. But on this last question here, we're showing you a multiplier of positive 6. When the multiplier is smaller than 1, what it's going to do is it's going to shrink it down in the vertical direction. But when the multiplier is bigger than 1, it's going to stretch it. So since we're talking about a 6, which is definitely bigger than 1, it pushed the values away from the x-axis, stretching them, which made the same shape, but, just looks a little different, which is why A is the correct choice. And that's the end of Swyk number 1. Good luck with the Swyk. Bye.